Hello, everyone. Apologies for not such a strong voice today. This is our fourth time presenting at the European Utility Week. When we first presented, the presentation was generally about blockchain and how it works. And then over time, we have focused more and more on actual real-world applications. And now it's a really good time for it because the technology has evolved and the speculation bubble has also bursted. So the global focus is really on the implementation. The scenarios, the shell scenarios just came out. And one of the highlights they have in the report is open platforms. And it's interesting because it aligns with this entire platform economy wave. But it is all about not just technological advances, but also how people will react to it, how people will use it, and how they will benefit from it. So where energy and blockchain is, we kind of check the pulse every year. We have this major event annually that's an energy and blockchain summit called Event Horizon. And we survey the startups that participate, as well as some corporates that have projects. And we see that there is, the most of the interest is still in the peer-to-peer IoT side, which was well introduced by our moderator, Mr. Hoyer, and increasingly towards demand response. The other use cases may look less busy in this pie, but actually some are closer to the market, and that's what I will try to explain. So the Energy Web Foundation, which I talked about the last few times I was here, is now a shared technology. There is an Energy Web chain. It was launched in June of this year after 2 test nets were launched. We as Grid Singularity are co-founders together with the Rocky Mountain Institute, a nonprofit from the US, which has global clean energy mission. So not a usual setup where a startup from Europe and a nonprofit from the US come together, and then they bring together over 100 energy companies globally, and where we have relatively conservative companies now acting as validators on the chain and running a shared platform decentrally without one party having impact on the rules. And so this decentralized governance is now in place, and it's an operation system. So it's a blockchain. So it's a core platform on which you can put an app. And the governance system is fully effective. It is also cost efficient, and there is a more optimal throughput compared to other solutions out there. So the Energy Web chain is there. It's real. Anyone can access it and check that there are now hundreds of smart contracts running on it. And these are some of the companies that are part of that. So the first step really in blockchain was to have the energy industry agreed on one shared infrastructure layer. So that's something to which we contributed as a startup so that we can then move with implementation of actual real-world applications. The next thing that the Energy Web did is to create this protocol, an open source protocol. And just to go back, the Energy Web chain is also public, it's open source. So this is generally the theme, that the way to collaborate and move forward with effective implementation is to work together on open source projects. So Energy Web Chain is an open source blockchain. EUW Origin is an open source protocol. So it's basically a provenance mechanism which traces the production of renewable energy, and in that way deals with a number of the issues in the market that you may be well aware of, including the admin, the red tape, the high transactions costs that come with it, the complexity, and the fact that that impedes small prosumers or even smaller hydro plants from participating in the system. And of course, lack of interoperability. So what what Origin did is that it put together a modular structure. First, you have to start right with the user registry, asset registry, who is issuing, and then how do you onboard those assets? How do you issue certificates? How do you make sure that there is no double accounting? And you create a platform. And one example of a company that went on and took this open source protocol and created a marketplace is Singapore Power. So if you go to this site now, rec.spdigital.io, you will see a renewable energy certificate marketplace, which is an additional service of Singapore Power Group. And there is a similar project implemented in Thailand, and there is a new project soon to be implemented in Europe. And then Engie also has a blockchain-based application that does this called Theo, a spin-off from Engie. So all of these applications are on the market. They are commercial, and these companies have clients that they didn't have before with an additional service offering. And what we're seeing is that while the traditional companies that buy certificates have established processes, they usually go for PPAs, there are now increasing number of companies that want to source their energy from renewables and that are interested in platforms that are simple. And this is what the blockchain provides, a simple, interoperable platform. And in the case of SP Group, another interesting fact is that they have partnered with IREC to be fully compliant with IREC standards. So there is that collaboration in place as well. So I just want to emphasize that that is one blockchain application that is already commercial and already running, and there are multiple companies providing that solution. So what the Energy Web does now is that it created this shared technology, it created the open source protocol, and the next step is creating digital identities and registries as an open source protocol, which could then be customized for different markets so that we can all take advantage of distributed resources for a range of applications. And again, the theme is open source and having the market really benefit from blockchain technology in that way. Now, another way to benefit from blockchain technology is to provide that as an additional service. So this is another trend where you have applications that are not merely blockchain-based, but they're adding blockchain to their offering. So, one example is Verve, which does so-called home device management, but it's really, it's one of those disaggregators that they're gathering information from different devices in one's home, and they're providing consumers with information that can help them adjust their behavior. And the next thing they want to offer with blockchain is that an ability to trade any surplus based on consumer behavior. And that's something they're pursuing as a possible offering. And we see other similar providers that are looking for blockchain as an enhanced service provision. Moving from that, if I remind you of my first slide, which was the pie chart and the peer-to-peer, you've heard about multiple projects trying to connect communities, have them trade energy among each other. Well, most of those projects were really simulations. They were POCs, and they were more about settling bills in a different way rather than actual trade. And so we as a company, Grid Singularity, then focused on a new business model and a new market design. And we're calling it the D3A, the Energy Exchange Engine. So it's a software, again, open source, that you can use to create local energy exchanges that increase transparencies, that avoid vendor lock-in, and that could potentially be compliant with the range of regulation in place. So what we do, and it's a similar diagram where you have IoT in the middle, is that we created a software that looks as regulatory compliance, that takes account of grid stability and provides this market access. So those are the requirements, the engineering requirements we put together when we developed the D3A. And so then, what you're doing is really transforming business models where a utility can provide something called a community as a service, and I will explain that next. Communities given market access. There are many advanced communities that even look for, self-sufficiency. TSOs are interested in balancing. Vendors have to be integrated in the system. They're part of the puzzle. Regulators have a role because they can embed compliance, and when you run the software, you can make sure it's compliant with that jurisdiction. And then the DSOs, of course, are now mainly interested in congestion management and a new source of flexibility to manage congestion. Finally, we have data scientists as the last piece of the puzzle, because the more sophisticated the trading strategies of devices are on the market, the more optimized these transactions in an exchange are. Otherwise, you really just have a dumb load and not more, right? So the D3A, again, is an open source development where we call on different parties to develop this software together. So what do we have right now? The two examples. What you see on the right is how our interface looks like. So I don't have the website here, but it's d3a.io, like d3a.io. And it's free, and you can simulate the grid. Currently, we used to have 1 day, now we have 1 week simulation. And my colleague will present the simulation later today at 4:15 here at the summit. Sarah Hambridge. So you basically, you digitize, you simulate the grid. You can optimize it, so you can use it as a simulation tool. And what we're working towards in the next phase is deploy, so that you can then, once you have optimized, you can then deploy and run the software. So what we call community as a service is allowing a community to more optimally connect and use their resources, possibly also, invest and manage a communal battery. And the way the regulation is in Europe is that there are these so-called renewable energy communities. So legally, at the moment, they're the only ones that can do that autonomously. Otherwise, it would be, an existing market actor who would provide an additional service or look into, opt in if there are these. So depending on what their interest is on the market. Now, you might wonder, where does blockchain come in? So this is an app that can run without blockchain. The blockchain would bring it additional capability, meaning that you would have full transparency and no winner-take-all, fear of one market actor taking advantage of the system for themselves. So if any of the market actors would want to give that additional transparency, then they would run the software as a smart contract on a blockchain. And then there are other enhancements, like just more effective clearance, but you can run it without. So that's another example of where blockchain provides an enhanced capability to a software. Just checking the time. And energy access is another one that you can take a flip side. On one hand, you can use it to make sure that a community is self-sufficient because they are strongly environmentally aware, and that's the goal they have. Or you can look at it, from a pure energy access perspective and help create microgrids that are more efficient, that are off the grid, and we know that that's an immense problem in many of the economies. So what can you do now with the D3A, right? I wanted to tell you, okay, this is where we're going. You can already configure and analyze a digital market, so you can already play with it. What we're doing next is that we are working with companies, including Engie, including some of the large DSOs in Europe. We will together organize a track at the Odyssey Hackathon to move forward and co-develop this idea and different use cases and get ready to deploy sometime later next year with the software. So these are the next steps, is to move from this analysis to deploy where the assets operate the grid. I mean, that's generally the vision. It is a complete change to the current market design. And that's why we're looking at it with policymakers, with different energy actors, to see how we can, sorry, that's my timer, how we can deploy sooner, considering the current legal requirements. So how can you join? You can test it. You can contribute to the library if you wish with different configurations, because then it's more usable for everybody else. You can follow what we do at the hackathon. And I left on purpose 5 minutes or more for additional questions that you may have about any of the apps, not just about what we do, because I wanted to present you with a wider picture.
Okay, any questions? You're a very quiet audience. Or I guess you presented it that well that everybody's clear about everything.
I'll be around if people want to ask.
Okay, maybe I have a question.
Okay.
You were talking about simulation, and the assets are in the end managing the grid. Mm-hmm. And you were talking about kind of markets. Is this simulation capability limited to market activities, or could you also integrate more technical things to extend the scope of it? So for example, switching procedures and stuff like that. So active components in the grid itself.
Right. So we started with a hierarchical market structure, and with a very simple strategies that are based on low cost. I mean, you can have more sophisticated strategies that are part of it. You can have vendors that put in additional requirements. That's why we consider these third-party providers that are integrated then in the software, because all the software does is provides an exchange engine, the way we call it. So any elements can be brought in by third parties. And so we're now, you may see on the map some of the vendors that we work with to make sure that they're open to having the software run on them. So, we're starting with a simple simulation that is already more advanced than, the simulations that are being run that are based on all the profile loads from 12 years ago, no smart meters. So it's already in advance. And yes, that ideally, as everybody comes in together, it becomes more sophisticated.
Okay, and that would include then also grid constraints, because not all the transactions might be possible.
Yes, so yes, we're looking how to integrate grid fees. And in the current simulation, we have some of those markets integrated that you can simulate. So not all the clearance mechanisms are already in, but some already are. And so what we're doing is that we're releasing updates monthly or bi-monthly and not waiting for a whole year. And then we inform everybody who has logged in, and they get updates and they get a video of the new features. So in the last release, we have integrated some of the grid fees already. Yeah.
Okay, and then I have a last question. That would be, if any other question from the audience? Ah, yeah, there. Can we have a microphone? Ah, good to see you.
And like I said, if you're interested to see the actual simulation, how it's put together, my colleague Sarah Hambridge will do that at 4:15 later today.
Hi, Henrik here. Just a short question. How do you see the trend is impacting the TSO?
So I can be frank here because I'm just a startup. There are two ways of looking at this, right? One way is they're one of the actors in the market, and they are interested in how does this affect grid balancing, right? Another way is, should they just be operating the exchange for everybody and going down to the consumer, which of course brings about a dilemma as to the roles of other, the retailers especially. So there is a philosophical concept there to be thought about. And it's not just what we do, it's generally about how do you aggregate distributed assets and who plays which role. And that's why I favor that blockchain be used at least in part as a solution, because you can bring that transparency on board and you can assuage many concerns that actors have about someone doing the winner-takes-all approach. Yeah.
Okay. Any other question? Okay.
Thank you.
Then just my last question out of personal interest, maybe that's also interesting.
Yes.
You talked about open source. So what kind of license is it?
So it's a GPL v3 license, meaning that if you continue using the software to create an open source product, it's free. If you want to close the application, then there is a license fee. So it's similar to Linux. And so what we foresee is that some of the development will be, or most of the development will continue to be open source. And if there is a license fee involved, then it would fund the rest of the open source development, because we're doing this really impact first, profit second. And so that at the moment, that's the approach.
Okay, thank you then. No questions? Okay, thank you, Anna. It was very interesting. And by the way, just to avoid any confusion, we don't have a panel session today, so you might, I'm happy if you want to sit there, but okay, thank you.